Today's video is going to be a bit more chill than all the previous videos I've been doing over the last few months where I've been tearing my house apart, and we're going to be building a nice little simple server to run all my home automation systems. So yeah, this machine will run all my home automation. So it'll run Home Assistant, Node-RED, and then various other applications that I'll be using as the core of my home automation system. And there's a couple of reasons why I want to build a dedicated machine for this, rather than either using a Raspberry Pi or something, or just running this all as a VM on a server. So the reason I want a dedicated machine is that I kind of want to keep all of the core of my home automation on a dedicated system that's completely separate from any other VM host that I have. Because when I have VM hosts, they're the sort of thing that I tinker about with, change and modify over time. Whereas home automation is a bit too sort of critical for that. I'd rather have a simple machine that just sits completely untouched and I don't tinker with it outside of making changes to the home automation. And that way I can mess about with my VM hosts, change them, try different things, and I'm not relying on them to host such a critical service in my house. On top of that, I also want to be able to use some of the outputs on the physical machine, because I want the audio output of this to feed into the multi-room audio system I'll be installing, so I can use it for making announcements and sending notifications around the house. And I'm also toying with the idea of using the video output on this to feed into the HDMI distribution system, so that I can either use this to display dashboards on connected TVs around the house, or potentially even display some sort of on-screen display to allow control of certain smart home systems from TVs around the house. This is something that Control 4 smart homes can do. The Control 4 controllers can actually have an HDMI output that would feed into an HDMI matrix, and then your various TVs around the house can actually control the smart home through an on-screen display. So I'm toying with maybe building something like that, and of course that would again require a dedicated machine with an HDMI video output. As for why I'm building something instead of using a device like a Raspberry Pi or a little mini PC, it's purely because I want something rack mount. That's literally the only reason. Realistically, a Raspberry Pi or a little mini PC would probably be a much simpler option. It would be significantly cheaper and probably more power efficient, but I just want to have a rack mount device. That's literally the only reason. So we're going to build a little rack mount machine here to do all of that. And as you can see here, it's going to be very simple. In fact, this is literally all of the parts that are going into it on the table right now. This is not going to be a powerful machine. It's not going to be overly complicated. But I thought it'd be just a nice little chill thing to build this, do a little video of it, and put this thing together. So in terms of the hardware, here's all the core components that will be going into this. For the motherboard, I'm using this little Asus Prime N100i D4 motherboard. So this is a little Asus motherboard that's got a built-in Intel N100 CPU. The N100 is more of a mobile CPU, or designed for like little very low power devices, mini PCs, that kind of thing. And essentially it's a quad-core chip, but it only has efficiency cores. It doesn't have any performance cores. So it's a very low power, very power efficient little chip, but it'll be more than sufficient for what we're doing here. So that's just soldered onto the motherboard, and yeah, that's all it is. Very simple little motherboard here. We'll take a look around it. So on the back, in terms of I/O, it's actually got quite a lot. We've got a bunch of USB ports, which could be useful for sort of certain wireless stick type device I might need to connect. Gigabit Ethernet, that unfortunately is Realtek, but hopefully it'll be fine. We've got HDMI and DisplayPort, which will be good for feeding out for a potential on-screen display. VGA, which is actually quite useful if I ever got a rack-mounted KVM console. Chances are that would be VGA. Serial, which may be useful for interfacing with other devices. And then it's got onboard audio as well, so we can use that to feed audio out into the audio distribution system. Looking at the board itself, it is actually pretty limited with what it has, but it's absolutely fine for what we need here. We have a single slot for DDR4 RAM, a single SODIMM slot. We have a pair of M.2 slots. One here I'll be using for an NVMe SSD, and then the other one, which is labelled for Wi-Fi, I might use or I might not. And that's because I have this, which is a Coral TPU module. This is a little AI accelerator module, and they're very good for computer vision applications. I might use this or I might not, or at least might use this in this particular machine. Because when I install my CCTV system, I want to try out using Frigate as an object detection platform, so I want to be able to detect actual objects, detect people, and do more advanced object detection than just basic motion detection that a lot of cameras support. And that would use this. But I'm not sure yet whether I want to build a dedicated Frigate NVR to do all the recording, or if I'll use another sort of third-party NVR, potentially Unify Protect, now they support on-VIF cameras, and then I would just use Frigate on the Home Assistant box, not recording any video, but purely for object detection, in which case I would install this Coral TPU in this machine here. I won't be putting it in now because I want to try this out in more detail later and figure out whether I want to use this machine for object detection or to build a dedicated NVR, but I do have that slot if I want to use it. A couple of USB headers, I think I already mentioned, a single PCIe 1X slot. I probably won't use that, but I do have the option in the future. Single SATA port. Yep, literally one SATA port. And then the other thing that's nice with this motherboard is it has onboard power, or it takes ATX power. Because ASRock also do an N100 motherboard, but the ITX version requires an external DC power supply. It doesn't have ATX power, so this takes more sort of standard power than that ASRock model. So yeah, very simple motherboard. The only reason I went for this is it was the cheapest one I could find, had an N100 CPU, and was from a reputable brand. It wasn't one of those sort of off-brand AliExpress things that didn't seem to include an IO shield. So yep, that's the motherboard. Of course, that's also the CPU, so that's got through most of the components. In terms of other components, we have the RAM. So we have a single 16GB stick of DDR4 RAM. Nothing that fancy at all. 16 gigs is probably more than enough, more than I'll actually need for this, but it's one of those things, it's so cheap to get more RAM, I'd rather just go for as much RAM as I could possibly need, and that way I don't need to worry about upgrading it in the future, I don't need to worry about taking the machine down to change the RAM, I can just chuck this in and it'll be fine for forever really. In fact, 16 gigs is the most it's officially supported by the N100. It can support 32 gigs, sort of unofficially, but I thought I'd stick with the max that it can officially support. Then for storage, we've got a 500 gig NVMe SSD. So I'm using a Sabrent Rocket NVMe 4.0, way more than this would need. I think this is probably a 4x with the SSD, and it's definitely like it's PCIe 4.0. This motherboard will not be able to remotely use the power of this SSD, but I may as well go for a decent SSD, decent performance, and then 500 gigs is way more than enough that I'll need for this. But again, it's one of those things I don't want to risk running out. Especially because this machine will be collecting things like time series logs and historical energy monitoring and all that sort of stuff. I want to have loads of storage, so I just don't need to worry about it. And realistically, going for a 500 gig SSD versus 250 gig or whatever, the cost difference is negligible nowadays. So yeah, that's the SSD we're going for there. Next up, we have the case. And here we have this little 2U case. This is from a company called X-Case in the UK. I'll try and remember to put a link in the description. And the only reason I went for this case was literally because it was the cheapest 2U case that I could find that I liked the look of. What I wanted for this is I wanted something that looked more appliance-y and not server-y, if that makes any sense to anyone or if that only makes sense in my head. But essentially I wanted something that didn't have sort of drive bays on the front and look like a server. I kind of wanted it to look more like a home automation controller. So I like this case because it doesn't have any kind of drive bays, it's just a very simple case that kind of looks more like an appliance. What's also quite nice is it actually has a removable dust filter, so it's actually got this like magnetic dust filter on the front that comes off. Didn't expect that. So that's quite nice. It's very short depth. This case is actually available in a bunch of different depths, so I just went for the shallowest one because it's an ITX motherboard. It doesn't need to be any bigger than that. It's fine. I mean, it was not very expensive. It's your classic cheap rack mount case. It's got quite sharp edges and all that sort of stuff. No sort of toolless top. It's all just screwed on. But again, all I needed was a very simple, very cheap rack mount case, and this fits the bill. Now, in terms of why I went for a 2U case rather than a 1U case, it's purely just for ease of building in. Building in a 1U case is really, really awkward because a lot of motherboards have components that are potentially too tall for a 1U case, and in fact, even a standard IO shield is too tall for a 1U case. So if you're building a 1U machine, you either need to buy specific motherboards that come with specific thin, special 1U IO shields, or you end up sort of cutting down IO shields to get them to fit, and I just don't like doing that. Realistically, I'd rather just get a nice 2U case, use up an extra U of rack space because let's face it, my rack's way bigger than I need. This will fit absolutely fine. I just have a lot more room to work with. So yeah, generally, I like to buy 1U machines. If I'm buying pre-made machines, I'm very much happy to go with 1Us. But if I'm trying to build something, I'd rather go for 2U or bigger just because it's much easier to work in. And with that, the final component we have is the power supply, which is in this very nondescript brown box. And that's because with a 2U case, power supplies can be a little bit awkward. This case can fit a standard ATX power supply, as we can see here, but the difficulty with 2U rack mount cases is that they are basically the same height as an ATX power supply, which means that if your power supply has a top mounted 120mm fan, the fan will get pressed right up against the edge of the case and won't get good airflow. Now this case here tries to get around that because it has a little vent in the top of it. So if you did put a power supply in here that had a top mounted fan, it would be able to suck air in through this vent here. However, I'm not a fan of really using that because then it would be very easy to accidentally slot another machine on top and block this off. I'd just rather avoid doing that if I'm building a 2U rack mount machine. So instead, I've got this power supply here, which is a Seasonic SSP 350ES. And this is a slightly awkward to get power supply. A lot of places don't sell it, but essentially it's a power supply from Seasonic aimed more at the industrial and the OEM PC building market. It's not the best value for money by far. These are pretty expensive for what you're getting, which is essentially a fairly basic 350 watt 80 plus bronze power supply. But they're decent, reliable power supplies, completely trustworthy, from a decent brand, and they have a rear 80mm fan. So in this case, that can go in there and the fan will be completely fine, no issues with the airflow because it'll have a rear 80mm fan and it'll suck all its air from the inside of the case. The downside of these power supplies is they are very expensive for what you actually get. I think this costs around about £68 or something to buy this from RS Components, which is where the place I could find it for really the cheapest. They're pretty expensive because at that price you could get a really decent regular ATX power supply that'd be a lot more powerful than this. But for this sort of application, this one's kind of ideal. The other option you can sometimes do with these 2U cases is you can get a smaller form factor power supply such as an SFX power supply and then get a bracket that will adapt it so you can fit an SFX power supply into the rear cutout for an ATX power supply. With that setup there, your smaller power supply, which may still have a top mounted fan, will sort of float in the middle of the case and therefore would be able to get enough airflow. So that's another option if you did need a potentially more powerful or more specialised power supply. But for this setup here, we're dealing with the tiniest little super low powered motherboard. This little 350 watt Seasonic power supply is way more than we're ever going to need. And in fact, this is a slight disadvantage of building it myself, because I would probably actually get lower power consumption if I bought a little Intel N100 mini PC with an external DC power supply. But because with this, I'm taking a 350 watt power supply and running it at barely anywhere near its rated capacity, so it's not going to be the most efficient thing in the world, but I'm happy with that trade-off just to get a nice all-in-one rack mount machine. It's not going to be for everyone, this sort of idea, but this is what I want to do. So with that, that's all the parts out of the way. So now let's get on with building this. Okay, so now let's start putting this machine together. It's going to be extremely simple, so I'm not going to go into too much detail with all this, and I'm probably going to end up upsetting some sort of PC building people because I'll inevitably do something wrong that's really not a big deal. But anyway, let's try and put this thing together. So first thing we'll do is just chuck the RAM in. May as well build the motherboard. There's not exactly many components going into it. Don't even know why I'm filming this, to be honest, but hey, I've had a lot of very long-winded videos recently, so it's nice just to do a nice simple video that I can finish in the space of a couple of hours rather than a video that's going to take me weeks to produce. So that's the RAM in there. Time to put the SSDs in, or the single SSD. It would have been nice to maybe have some sort of rated SSDs, but obviously this motherboard isn't going to support that. Realistically, when I set up the software on this, I'll be installing it with I won't be installing Home Assistant OS, but I'll be installing Home Assistant in supervised mode, so it'll be able to back itself up. So I'll probably have this machine automatically back up all its configuration and software to my NAS, so I can easily restore it in the event of a SSD failure, which almost certainly will not happen because the SSD is getting very, very little action. But yep, that's the SSD there. I kind of like the packaging of these Sabrent drives, but equally it does feel very wasteful when it could just be an anti-static bag. But anyway, that's the likely completely over-the-top SSD there. Need to put the standoff in, which it's a 2280, so that's going to go in there. Don't really know why I'm filming this, but I suppose it's kind of like a PC building, ASMR, good background audio type video to watch, I suppose. So now with that in there, let's stick the screw in for the SSD. Like that. And then what I'm also going to do is the motherboard came with the screw for the other M.2 slot as well. I'm just going to put that in as well. I'd always say that if you're building a machine that comes with multiple M.2 screws and standoffs and all that kind of stuff, just install them all into the motherboard, because chances are when you come to install another card in that slot down the line, you won't be able to find the motherboard box or the bits that came in it. So just leave all the screws in there and then at least they're always available for you. And with that, that's the motherboard built. So that was extremely simple. This is going to be a very quick build. So yep, motherboard's all ready to go. I've already unscrewed the screws that hold the case together. It's a shame it's not toolless, but it was cheap. I can't really complain. And here we are inside the case. Actually, to be honest, just a bit of feedback, that is pretty sturdy metal though. So even though it's got quite sharp edges, it does feel like a pretty substantial case, which is good. Bag of little screws there. Various headers we've got. So we have, what on earth is going on here? So we've got, right, okay. So we've got a USB header here. So it's USB 3 here or USB 2. Actually, it'll make more sense if I show the front of the case. On the front of the case, there's a USB 3 connection and a USB 2 connection. Now what they've done here, I'm not a huge fan of, but it's fine I suppose, is the USB 3 port on the front breaks out to a USB 3 header or a USB 2 header. So if your motherboard doesn't have USB 3, you can use the USB 2 header to connect the 3.0 port up at USB 2 speeds. Separately to that, we have this other board here that has all the LEDs on it and the USB 2 port. So with these headers here, we have the LAN LED, hard drive LED, power LED, reset switch, power switch, and then we have this USB header here, which is for the USB 2 port. So that, I've not seen that before. I've not seen a header like this used for USB before. It's always, an actual USB header. I mean, it'll work, but it's a bit cheap and nasty, especially given on this motherboard, the front panel I/O is all down here, and the USB 2 header is all the way up here. So I have to strip this all the way back to connect it to there. To be honest, I might just not use connect the USB header up. I don't really need the front USB ports, but we'll figure that one out. But yep, this is inside the case. We've got standoffs in there. I'll need to check if they line up. I might need to install more standoffs. It's got space for a couple of hard drives. I think you can fit, 2 3.5 inch drives in there, and then a 2.5 inch drive. I'm not going to use any of those at all. And then you get a single 80mm fan installed in the front. Again, not the fanciest thing in the world. Definitely a pretty cheap fan, but I'm sure it'll do the job. It's nice that it at least does connect to the motherboard, so it's not like I had to run a Molex to it, but it isn't speed controlled or even speed monitored. I'll use this for now and see how I get on with it. I think I have a nice 80mm Noctua fan kicking around somewhere, but I have no idea where all my PC parts are since the move, so I might swap that out in the future, but we'll see. So yep, time to get the motherboard in, so we'll get the standoff sorted. Most of the standoffs are in the right position, so I think I just need to install one into this space here. These are actually really nice standoffs. Yes, this is such a boring video because I'm literally talking about standoffs, but they actually have a slot for a slotted screwdriver for tightening them up. Not seen that before. I know people are probably shouting at me because this is probably super common in all gaming cases on the market nowadays, and it's just been so long since I built a PC, I haven't seen them, but anytime I've had them before, I've had to use a hex driver to do them, so that's quite nice. So yep, that's in there. Time to now screw the motherboard in. Oh, as you know, I/O shield first. So make some horrible squeaky noise with the plastic and put the I/O shield in, like that. And now get the motherboard in. So get that in there. I'll then find the motherboard screws and get that screwed in place. So we have the screws. Let's put this all in here. These 4 screws into the motherboard. And now with the motherboard installed, we're basically most of the way there. So next up, we'll get the power supply in place. So that's going to have to go kind of upside down because of the layout of the screw hole in the back. Hopefully that actually fits. It's a bit tight for the cables. Yeah, that'll fit, and I'll be able to just kind of stash the excess cables inside those hard drive bays that I won't be using. Equally, I could actually take them out and get even more space, but may as well leave them in there just from the perspective of if I did ever want to install a hard drive or something in the future in here. Not that I probably will, but yeah. What I'll do is because it'll be way too boring to show on camera, I'll just try and get these cables separated out so I've got the right cables for the motherboard plugged in, and then we'll kind of bury the rest of them away in those hard drive bays and I'll get it screwed in. Okay, so that's now the power supply installed and the cables are kind of tucked in there. I'll probably go away off camera once I've finished it all and tied them up a bit and tidy the cables up a little bit more. It's one of those things that's really awkward to try and film. So now I need to put the 8-pin EPS in, making sure I get the right one, because it's one of those split ones. It's going to be that one. Cool, it's got it's a 4-pin EPS, not an 8-pin, it's a tiny little motherboard. Like this is a very, very low power motherboard. I think the TDP of this chip is at 4 watts or something. It's a tiny little super low power chip. So yep, get this in there. What am I doing wrong? Have I got that the wrong way around? Yep. It's been a while since I built a PC, so yeah. It's coming back to me, but yeah. It's not something I do super regularly. So there we go, that's the EPS and the ATX connector connected. I'll need to tidy all this up off camera. So yeah. What I'll now do is I'll go away, I'll get the fan connectors in, get all the front panel I/O in, and then I'll tidy the cables up because nobody wants to see me try and do that. So yep, I'll get those in and then we'll come back. And with that, the machine is now built. It was extremely simple, but it's all now together and hopefully will work. So cable management, of course, in a rack mount case, there's basically not much you can do. So all the power cables are sort of tucked off into this sort of drive bracket and just tie them in there to keep them neat. The USB headers I actually brought under the motherboard. They were quite thin, so I could easily fit them under there and then loop them up into the motherboard, and it just means that they're not snaking around, especially because around here we need the airflow from the fan to potentially cool the CPU. It won't need much because obviously it's passively cooled, but a bit of airflow will be good, and then just tie the excess of the front panel connections up there. And yeah, it's not the prettiest thing in the world, but it's perfectly neat. So yeah, that's kind of the inside of it there. The only thing I did end up actually connecting up that USB 2 connection just because it would bug me if I didn't have if I had a USB port that didn't work. And in some ways it is quite nice just because it means that even though it's on the USB header here, the row of pins for the second USB port aren't actually covered. So it meant if I ever installed any additional hardware into this that needed to connect over USB, I do actually have a spare USB header there because this motherboard only has that USB 2 header. And I might actually end up doing that in the future because with this machine here, I may end up installing some sort of relay hardware inside here to allow this to have a 12 volt output that can be switched on and off from software to turn my amplifiers on and off as part of the audio setup. That'll come in a future video. But if I did install that, likelihood is that would interface over a USB header, so having a spare USB header actually is quite convenient. The only problem is this USB header is completely unlabeled and doesn't have any kind of keying on it, so there's literally no sign. I mean, it turned out that the red line was the 5 volt pin, so that kind of worked, but I literally had to bail out the USB port with a continuity tester and try and work out what pin out this was. It's a bit rubbish. There's no manual with the case either. I think it's the sort of thing that this case is probably built for sort of system builders that would just know that, but if you're only building in this case once or once very occasionally, you wouldn't know that straight away, but it's fine. That's now in there. So yeah, this machine put together there. I think what we'll do now is I'll be overconfident and put the top back on straight away rather than testing it with the top off first. We'll get some sort of KVM console hooked up to this and we'll test it out. So there we go, that's the machine all now put back together and connected up. So I've connected it to my laptop. This is a thing I've made videos on before. It's not a laptop, it's basically a monitor, keyboard and touchpad in a laptop style case. So that's what we're using here. So that's connected up to this over USB for the keyboard and touchpad and then HDMI for the video. If you want to see more on this, I'll put a card up on the screen with a link to that video. But now let's power this on for the first time. And this is genuinely the first time I've powered this on, so if it all goes bang, well, we'll see it live. So power supply on there, hit the power button and hopefully it works. Yep, that's it booting. Power LED is flashing, but with this motherboard, that's actually kind of like a post code thing. Essentially, it flashes the power LED to show the post status, which is quite clever. Oh, and there we go, it's booting. So press delete to enter BIOS. I'm sitting there pressing escape, but we're in. Quick without saving, no. And we're in. With probably the most basic BIOS. This is, like I was expecting, obviously it's a very basic motherboard, but I was expecting this to have one of those like modern Asus, you know, graphical BIOSes, but nope, it is literally the most basic BIOS you could possibly get. But absolutely fine, I'm not complaining. I actually don't really like those modern BIOSes. I'd rather have something simple like this that's much quicker. And yeah, we're in. So we can see we've got the Intel N100 CPU, 800 MHz base clock. Of course, it goes a lot higher than that when it boosts. But yeah, the base clock is 800 MHz. It's detected all the RAM. It's detected at the full 3200 MHz frequency. So yep, that's all fine there. And do we have the SSD detected? Where would that be? Boot configuration? Where would the SSD be? PCI? No. What am I doing? NVMe. Yep, there we are. There's the SSD. Cool. SSD is detected in there. 500 gig Sabrent Rocket. Yep, the SSD's in. So, in theory, this machine is now good to go for installing an operating system. So I'm not doing that on camera because I personally hate making software videos. So I'm going to get this all installed, set up, get Home Assistant installed, and we'll come back when it's all working. It would be nice to do a dedicated video showing the software setup. I just really hate doing software setup videos, so there's better videos out there on YouTube on how to do all this. So I'm going to get some sort of Linux distro installed, probably Debian, install Home Assistant in supervisor mode, and then we'll come back when it's all working. And with that, we have the whole machine up and running and working. So I've gone away, I've set up all the software, so I installed bare Debian Linux on it, and then on top of that, I then installed Home Assistant using the supervised installation method. So that means that I have equivalent functionality to running Home Assistant OS, so I can use the add-ons, I can use built-in updates and backups and all that sort of stuff, but it also allows me to customize the underlying OS a little bit more. What I've also done when I've installed the OS is I've set it up using an LVM file system, and I've set it up so the root partition is a fair bit smaller than the full drive, and I've left a fair bit of unused space on the drive inside the LVM volume group. What that means is I can then easily take snapshots of the file system and then revert back to them if I need to. I'm not going to be taking these as like a rolling basis or anything like that, but it means if I was to ever say do a big update, say a big Home Assistant update, or in fact update the underlying operating system, I can take a file system snapshot, check the update works, and then I can either remove the snapshot if it did work, or I can revert back to it. Because with something like this that is so critical to my smart home operating, I don't want a bad update to mean that I have to take this all down, completely rebuild it, reinstall software, reinstall Home Assistant from a backup. I want to be able to very quickly just revert to a snapshot of the file system. So using LVM makes that very easy. So yep, done that. I've already tested it out, creating some snapshots, reverting back, and it works perfectly. You can also see I've kind of decorated the machine a little bit. Just put this little Home Assistant logo on it here. If people are wondering how I did that, I used my Brother label printer that I seem to be talking about in literally every video at the moment. But I used this with a 24mm black on clear label. These clear labels are absolutely fantastic for things like this, because you can just print out a black logo on this, stick it on the front, and from any kind of reasonable distance, especially when it's not under bright lights, it doesn't even look like a label, it looks like it's almost printed on. Those clear labels are great in general, even if you're, say, labeling a socket or a switch, because if you use one of those, it means that if the switch is slightly off-white compared to using a white label, you don't see the label as much. They're absolutely brilliant. But yep, I've printed that on there just to kind of just decorate it a little bit. Fairly pointless, but, well, may as well, looks nice. So yeah, that's everything up and running and all the software installed. And now, of course, I've got an absolute ton more software set up ahead of me. I've got to actually get Zigbee, I've got Zigbee MQTT installed, but I've got to get that configured, get all my Zigbee devices enrolled into it, get everything working again. That's going to be a huge project. That's not going to be in this video. So all we need to do now is get this down into the rack, wrap up this video, and then I'll go away off camera and we'll get everything set up. And with that, the machine's now installed in the rack and working. So yep, I've mounted it in there. I've left a gap between the other devices. Doesn't really need it, but just looks a bit nicer separating it all out. And yeah, I think that looks really good in there. Definitely glad I went for that case because it really does kind of look more like an appliance rather than a sort of full-on server. The other thing I forgot to mention earlier is that the other setting I changed in the BIOS was to make sure that this powered on in the event of a power failure. So as soon as mains power is applied, this will power on. Which is quite an important thing to do if you're ever building something with a desktop motherboard that you're using as a server. Because if you don't do that and there's a power cut, it won't turn itself back on. So easy to change that setting. So now if there's a power cut, that'll turn itself back on. And then the only other thing you might have noticed is that the power LED on this is flashing. Now, this is a thing with this particular motherboard, whereas rather than putting a sort of 7-segment display on the motherboard or a set of LEDs on the motherboard to show sort of health status and postcodes, this one does it by blinking the power LED. And this sort of slow blinking it's doing right now is indicative that there's no monitor connected. And for some reason it deems that to be enough to sort of flash an error code almost. Now, I could turn that off in the BIOS and instead basically disable that postcode readout and just have that work as a normal power LED. But equally, it's probably quite nice to have that there, so if there is a problem with it that's more important than there not being a monitor connected, I'd potentially be able to see it from the status LED flashing. So I'll just live with that flashing there, it's not really a problem. But just if people are wondering why that's flashing, that's why it's doing that. So yeah, I've not got the power LED and hard drive LED headers or something mixed up. So yeah, that's it all installed in the rack and working. Of course, I've now got an absolute ton of software set up to do, so I'll go away and do all that off camera. But yeah, that was a pretty fun little build. Nice, more sort of relaxing video than the previous ones I've been doing. So hopefully you found that interesting. But all left to say now is thank you very much for watching.